Okay, so let's talk about table 3. Okay, table 3. So basically we are talking about the standard normal z, right? So z is standard normal. So this means mu is 0 and sigma is 1. Okay, sigma is 1. So mu is important, right? Mu is 0 means the middle of this curve is 0, right? It's 0. So you can also see here on the table 3, they label the middle of the picture on the x-axis 0, right? On the x-axis 0. So now what is the numbers in this table means, right? What the numbers in this table means? It means so if you cut this whole graph to two parts, right? Two parts. Then the area to the left of the cutting line is in this picture. It's in this table 3. Okay, table 3. So table 3, this table is the area to the left of cutting line Z. Okay, so you will be given Z equals to a number, right? Z equals to a number, and then the area to the left means the number in the table 3. Okay, table 3. So now what this means in probability? Okay, what this means in probability? So you think if this is cutting line is Z equal to A, then this area is equal to the probability that Z less than or equal to A. Okay, less than or equal to A. So the area is to the left equal to less than. Okay, equal to less than. And this number is in table 3. So now if you look at the yellow part in this table 3, so that's the area to the right of the cutting line, right? To the right of the cutting line. So to the right means greater than, so this is Z greater than or equal to A. So this is the area to the left of the cutting line. So it's 1 minus the blue area. The total area here is 1. Okay, so it's 1 minus the blue area. And then the blue area is less than, and then the blue area is in table 3. Okay, it's in table 3. So that's the meaning of the picture on this table. Okay, meaning of the picture on this table. And then you can see this table has 2 pages, right? So the first page, on the one on the left, is for the negative cutting line. Okay, negative cutting line. And then the blue area is smaller, the yellow area is bigger. And then the second page is for the positive cutting line. Okay, positive cutting line. Then the blue area is bigger, and then the yellow area is smaller. Okay, yellow area is smaller. So now let's look at some examples. Okay, some examples. Okay, so let's first assume the cutting line is Z equals 1.82. Then the blue area in table 3 means the probability Z less than or equal to the cutting line. Okay, less than or equal to the cutting line. Okay, and this number is in the table 3, right? It's in the table 3. So now how can we use this table, right? How can we use this table? So first you have to find the row. So the row is 1.8. Okay, yeah. So the whole number part and the first decimal digit give us the row. So this is the row 1.8. So we are only looking at those numbers, right? Those numbers. So 1.8 is the row. And then this second digit is number 2. So second digit is number 2. We use the green color because the second digit is green on top of the table, the first row. Okay, the first row. So the first row gives us the second digit in the given number, right? So this is 0, 0. Second digit is 0. 0.01, second digit is 1. 0.02, second digit is 2. So we need this. So this gives us which number in the row or which column we need in this table, right? We need this table. So this is the third number or third row. Okay, so the third number is the answer. So the answer, the area is the blue area. Is 0.9656. Okay, so this is the number in table 3. So the meaning is if you cut the picture for standard normal, the cutting line is at positive 1.82, and then you have a big blue area and a small yellow area. Right, the big blue area is 96.9656 from the table 3. Okay, okay, so you find the row, you find the third number on that row, that's the blue area. So now what's the yellow area? The yellow area means the z is bigger than 1.82. Right, to the right, okay, to the right. So it's 1 minus the blue. Okay, yeah, so this yellow area is equal to, let's move it here a little bit, is equal to 1 minus 0.9656. This is 0.0344. Okay, 0.344. So the yellow area is very small. Okay, it's very small for this particular case. Okay, for this particular case. Okay, so this is 1.82. So now let's look at, if it's not 1.82, right? Let's look at another example. Okay, so now let's assume the cutting line is 1.18, right? 1.18. Okay, so now the row is 1.1. So 1.1 is this row, right? Is this row. And then look at second digit is 8. So second digit is 8, so this is the column. So the second number from the right is the answer, right? Is the answer. So we got the probability z less than or equal to 1.18 is 8810. Okay, 8810. So now you want to find the yellow area, right? Yellow area means greater than. So this will be 1 minus the blue. This is 1 minus 0.88110. So this is 0.118119, right? 119. Okay, yeah, so that's our second example. So now let's move to the negative side, right? Let's move to the negative side. So if the cutting line is negative, right? Like cutting line is negative. So let's look at z is negative 2.26. Okay. So now in this case, the blue area is smaller, right? The blue area is smaller. So the number in table 3 means the area to the left of the cutting line. So 2.2 is the row, right? 2.2 is the row. Negative. So now let's find this, negative 2.2, so that's the row. So this row. And then number 6, second digit number 6, so this is the column, right? This is the column. So the answer is this one. So it's 0.0119. Okay, 0119. So the second digit, decimal digit, give you which number in this row, right? Which number in this row. So this is less than, right? This is less than. So now what is greater than? So PZ is greater than or equal to negative 2.26. So that will be 1 minus the blue area. One minus 0.11. 0.0119. So this will be 0.98. 881. Okay, 881. So the yellow area is a big number. Okay, it's a big number. Okay, so this is the meaning of table 3. You're given a cutting line. The area to the left is in the table. The area to the right, you need 1 minus that number. Okay, 1 minus that number. Okay, so this is case 1, right? It's Z is standard normal, right? It's standard normal. So now what is case 2? So case 2, you are given the letter X. So now we know X is normal. And then the mu is given, and then the sigma is given, right? The sigma is given. Okay, so the mu, they call this the mean of this variable, and then sigma is the standard deviation, right? Deviation. So these two numbers will be given. Okay, 2 numbers will be given. Okay, yeah. So now let's look at example. Okay, so this example is in the lecture 10, right? Lecture 10. So they said, okay, X is normal, and then they tell you the mean and the deviation, right? So mu is 115, and sigma is 13.3. Okay, 13.3. So now for this kind of question, we will need to change this X to Z to standard normal. And use table 3. Okay, use table 3. Okay, so now what is question A here? Question A is at least 140 minutes to finish the final, right? Finish the final. So that means probability X is at least, so it's greater than or equal to 140. Okay, 140. So that's question A, right? That's question A. So now let's solve question A first. So question A is X. So how to change X to Z? So Z is X minus mu divided by sigma. Okay, so that's the formula, and this formula will be given. Okay, this formula will be given. Okay, yeah, but you need to know when you should use this formula, right? So first condition, X is normal, and then mu and sigma given, then you can use it, right? Then you can use it. So this question A greater than or equal to 140, that means the cutting line is X equals to 140, right? 140. Okay, equals to 140. So this formula, the idea is, so this is the graph of X. Mu is in the middle. Mu may be not equal to 0. And then we have another picture. This is the graph of Z. And then 0 is in the middle. Okay, 0 is in the middle. So table 3 is the area here. So if you cut here in the Z picture. Okay, so there's a cutting line in Z picture, but it's not given. So they give us the cutting line 140 in the X picture, right? In the X picture. So I should move this Z picture a little bit because it's bigger than the middle, right? Bigger than the middle. So the given cutting line is in the picture of X. So this is X equal to 140. And then the blue area is less than, but they don't want to find the blue, they want to find the yellow, right? They want the greater than, okay? The greater than. So this formula will change the graph of X to graph of Z. Okay, to graph of Z. So we know for X, the cutting line is 140. So now what is the cutting line here in the Z graph? Okay, in Z graph. So use this formula, you'll find this new cutting line. Okay, new cutting line in the picture of Z, which is standard normal. Okay, which is standard normal. Okay, so now let's calculate this new cutting line, right? Calculate this new cutting line. So this is X is 140, the cutting line, minus the mu 115 divided by sigma 13.7. Okay, it's 13.7. Okay, so I will skip the calculator step. So this is 1.82. Okay, this is 1.82. So now question A, they have the inequality P is greater than or equal to 140. Now we translate that to the picture of Z. So it's the same direction of the inequality. Now 140 change to 1.82. Okay, 1.82. So now we can use table 3 to find this probability number. Okay, this probability number. So now let's finish this calculation, right? Let's finish this calculation on top of this page. Okay, so we need, first we change the probability of X to probability of Z by using the formula, right? Formula. And now we need table 3, right? Probability Z greater than or equal to 1.82 is 1 minus, that's the yellow area, minus the blue, right? And then 1.82 is our example, right? Is our example. So in table 3 is 9656.9656, right? Yeah. So we already used this number in the previous example. So later I will show you this again, right? So let me calculate this subtraction. So it's 0.0344. Okay, 344. So the answer for X is greater than 140 is this number, 0.344. Okay, yeah. So where did I find this number in table 3? So let me show you again, right? Let me show you again. 1.82. So 1.8 is here, right? So this is the wrong pen. Okay. So 1.8 is here. This is the row we need. And then it's 82. Second digit is 2. So this is the one. So 59656. Okay, 9656. So that's the blue area to the left of the cutting line in table 3. Okay, in table 3. And then we need the yellow area, so it's 1 minus. You got the answer. Okay, you got the answer. So for all the questions in the lecture 10, the first part, you need to change X to Z. Okay, change X to Z. So now let's look at the second part, right? Let's look at the second part. So now let's write down the given information, all the numbers, right? All the numbers, what this number means. So this is for variable X. So X is normal. Mu is 115 and the sigma is 13.7. Mean and standard deviation, right? Standard deviation. Okay, so we already solved A. So A is done. Now let's look at B. Let's look at B. So this said we select class of 28 students. And then they want the mean completion time. So they're taking the average of these 28 students. Okay, 28 students. So we get a new variable X bar here. Okay, so this is the mean of 28 students. Okay, so it's the average completion time of 28 students. So now what does N mean? What does 28 means? 28 means the size of the sample, right? So we use letter N for that. This is the size of the sample. And then we get a new variable X bar by a theorem, central limit theorem. We have X bar is normal. X bar is also a normal distribution, okay? And then you have the same mu, 115, but a new sigma. So sigma X bar is the sigma given sigma divided by radical n, right? Divided by radical n. Now let's calculate sigma X bar, right? Sigma X bar is sigma, so this is 13.7 divided by radical 28. Okay, radical 28. So use calculator, you got this is 2.59. Okay, 2.59. So question A, we change X to Z. Question with the mu and sigma. Part B, we change x bar to z with this new sigma. Okay, same mu, new sigma. Okay, new sigma. Okay, yeah. So now what's the cutting line for this? Question B is 110 minutes, right? At most 110 minutes. So the question B is the probability x bar is less than or equal to 110. Okay, so this is the one we want to find. Okay, this is the probability that we want to find. Okay, so we have the same mu and a new sigma 2.59. Okay, 2.59. So now let's calculate, change this x bar to z, right? Change x bar to z. So we will have exactly the same calculation as part A now, after you got the new sigma, right? So x bar is normal. And then same mu, 115, 115. And the new sigma, so the one we just got is 2.59. Okay, so now z is x bar minus mu divided by sigma x bar. Okay, sigma x bar. So now what is x bar? The cutting line is 110, right? The cutting line is 110. And then this time we want to know the area to the left because they said at most. So at most is less than or equal to, at least is greater than or equal to. Okay, greater than or equal to. So we got 110 minus 115, the mu, divided by 2.59. Okay, so this is about negative 1.93. Okay, 93. So now we just need to find the probability. So now the probability question for x change to the probability question for z, and then it's less than, so it's in table 3, right? So let's write it down. X bar less than or equal to the cutting line 110. So now for the new z picture, the new cutting line is negative 1.93. And this is in table 3, right? Table 3. So now I will write down the answer and then show you table 3 again, right? So this one is 0.0268 in table 3. Okay, in table 3. Okay, so now let's go to table 3, find this new cutting line, negative 1.93. And then the area to the left supposed to give us this one, right? 0.268. So now let's go to the negative side of table 3, right? So negative 1.9. So negative 1.93, right? 93. So negative 1.9 is this row. And then the second number is 3. So this is 3, right? This is 3. So that's the number. That's the area, right? That's the area. In the row, this is the row, negative 1.9, and then the fourth number from the left, so it's 0.0268. Okay, 68. So then we solved the B part of this question, right? The B part of this question. So what's the probability? If we change this to probability, move it 2 places, so this is about 2.68%. Okay, 2.68%. Okay, so that's the question in chapter 10. So which is the third case, part A, we change x to z. Part B, we change x bar to z, right? X bar to z. Okay, so now let's look at the lecture 12 question, right? Lecture 12 question. Okay, so now let's first write down what is given, right? What is given, okay? And this is a very important part. This will tell you, okay, this is the hypothesis test question. Okay, hypothesis test question. Okay, they give you the level of significance. So in the book, they use the letter alpha for this small percentage. Okay, so alpha is small, 5%, 1%, 0.5%, or maybe 0.1%. Okay, yeah. So you are given a small alpha. Okay, a small alpha. So now what do we want to calculate? We want to calculate the p-value for this question. Okay, p-value for this question. But now let's first write down what all these given number means, and then we talk about what's p-value. And then p-value is very similar to what we did. We have to use x bar, and then we change x bar to z to find the p-value. Okay, to find the p-value. So now let's write down what's given. So first, mu is 28. And then they have 7 blood tests. Okay, 7 blood tests. So example mean. Okay, when you read it, you have to read it very careful. Okay, so example mean is x bar is 29.8. So how many times you did the blood test? 7. So this 29.8 is the average of the blood, average of the 7 tests. Okay, 7 tests. So we use letter N. This N is the sample size. Okay, you are taking average of how many numbers, right? How many numbers? So now 7 is done, x bar is done. Okay, so now the next one, they said x is normal. Then for any normal distribution, we already know mu is 28. We need sigma, right? We need sigma. So sigma is 4.52. Okay, 4.52. Okay, so these are all the given informations. How many numbers are given here? 5, right? 5. Okay, so now like the previous case, there is x bar, so definitely we need a new sigma, right? A new sigma. So let's calculate the new sigma first. Okay, new sigma first. So sigma x bar is sigma divided by radical n. So here sigma is 4.52, and then n is 7, so this is radical 7, right? Radical 7. Okay, yeah. So the new sigma is about 1.71. Okay, 1.71. So x changed to z is the first part of lecture 10. X bar changed to z is the second part of lecture 10, right? Second part. So now let's do that part, right? So now we know x bar is normal. So now this lecture 12 question is very similar to the one in lecture 10, right? And then same mu. So we still got 28, and then sigma x bar is 1.71. Okay, 1.71. So now we can use these three numbers, change x bar to z, right? X bar to z. Okay, yeah. But now there is a problem, right? There's a problem. Okay, there's a problem. So we know where is the cutting line, right? We know where is the cutting line. So this is the cutting line because x bar is 29.8, right? So if you draw a picture for this x bar, right? X bar is normal. So mu is 28. Okay, 28. And then we got example, and then we do the test 7 times. We calculate their average. We got this new cutting line 29.8. Okay, 29.8. So now we don't know which direction we should go, right? So we want to know the blue area to the left of the cutting line, or we want to know the yellow area to the right of the cutting line. Okay, the right of cutting line. Okay, so now we have 2 things to do. First, we have to change this picture to a standard normal picture of z. So now 0 is in the middle. So now 29.8 will change to a new cutting line. And then we have to figure out we want the left or right area, right? Left or right area. So now let's do it between 2 separate steps, right? 2 separate steps. So first, let's change this cutting line to the cutting line in the standard normal picture. Okay, standard normal picture. Okay, so I deleted everything, but I kept the x bar, mu, and sigma x bar because we need them to change the cutting line to the z, right? To the standard normal. Okay, standard normal. So z is x bar minus mu divided by sigma x bar. So this is 29.8 minus 28 divided by 1.71. Okay, 1.71. So now we got the new cutting line is 1.05. Okay, 1.05. So it's here. Okay, it's here. So we change x bar to z like the previous example, B part in lecture 10. And now we have to decide. We choose the blue or we choose the yellow. Okay, we choose the yellow. So now let me explain that part, right? Let me explain that part. So for this kind of question, hypothesis test, we basically choose the smaller area. Okay, after you know where is the cutting line, we choose the smaller area. Okay, so now let me write down two cases. So let's change to the green color. So suppose this is the picture of x bar, right? So this is case 1, and then this is case 2. So they are both the picture of x bar, okay, the graph of x bar. So we know mu in the middle, but we have two cases of the cutting line, the red line, right, the red line. So cut here or cut there. Okay, cut here or cut there. So if the cutting line is on the left, then we find the blue area. If the cutting line is on the right, we find the yellow area. Okay, yeah. So the idea is we find the smaller side. Okay, we find the smaller side. So by definition, this is called the p-value. Okay, so p-value. So p-value is the smaller area after you have the cutting line. Okay, after you have the cutting line. You know cutting line is on the left, then you go to left. You know cutting line is on the right, then you go to right. You get the yellow area. Okay, yellow area. Okay, so now for this particular example, right? We have this one, right? We have this one. So the cutting line is on the right, then the yellow is less than blue. We need the yellow area. Okay, we need the yellow area. So in the book, they write down the inequality. They basically compare the cutting line x bar and mu, right? So this case 1, they said x bar is less than mu because it's on the left. Then p-value is this blue area. And in case 2, x bar is bigger than mu, and then p-value is this yellow area. Okay, yellow area. So the picture is very helpful. Then you don't need to remember so many definitions. Okay, so many definitions. Okay, yeah. So now let's write down the p-value part, right? P-value part. So for this particular case, for this question, we know p-value is the yellow area to the right. Okay, so p-value is the probability. Look at the x picture, yellow part. So it's x bar greater than or equal to 29.8. So now we already changed x to z. So this is the same area for z greater than or equal to 1.05. Okay. So we change it to z because we need to use the table 3. And we know table 3 is 1 minus, right? Is 1 minus because it's greater than. So 1 minus p of z less than or equal to 1.05. So now in table 3 you can find this one. So I skip that part. 0.8531. We already used table 3 a lot of times, right? A lot of times. Okay, so this is the step. We use the table 3. And then 1 minus that, right? 1 minus that, the final answer is 0.1469. Okay, 69. So what's the bad news for this question? Right? What's the bad news for this question? This is still not the end of this question 12.3. Okay, so we changed x bar to z, and then we define something called p-value, and we find the p-value. So this p-value is about 14.69%. Okay, 14.69%. So now what's the last step? We still didn't use the letter alpha yet, right? We have to compare this p-value to alpha. Okay, compare this p-value to alpha. So that's the last step. Okay, so if p-value is bigger than alpha, okay, so that means x bar and mu are close. It's okay. You don't need to vary it. You don't need to change anything. Okay, so that implies keep mu. Okay, so the red blood cell volume is okay for Mercedes for this particular example, right? For the particular example. So this is the case for this example. P-value for this example is 14.69%, and then the given alpha is 5%. Okay, 5%. So this is case 1. Okay, case 1. So now case 2. If we after we calculate p-value, but p-value is less than. P-value is less than alpha, then we have to change mu. Okay, we have to change mu. So that was this question about, right? So now let's look at what this question, what did they ask, right? What did they ask? So they want to know that this given information, the given delta, indicates Mercedes the mean red blood cell volume is greater than 28. So they want to know whether mu should be greater than 28 for Mercedes, right? For Mercedes. And we know our p-value is greater than 5, greater than the given alpha, which is the level of significance. So that's not the case. Okay, that's not the case. So alpha is kind of a standard. Okay, it's kind of the standard. Okay, so finally let me use the picture to explain alpha again, right? To explain alpha again. Okay, so this is the graph of x bar. So mu is in the middle. So let's use another color for mu in the middle, right? Mu in the middle here. And then let's use the red for the cutting line. And you have a right cutting line x bar here, right? X bar here. So p-value is the smaller side. So this side is the p-value, right? This side is the p-value. And then we're comparing this to alpha. Alpha is a standard, okay? So let's use purple color to 5%, right? So they pick 5%, so that means we pick a very small cutting line on both sides. So for each area beyond these two cutting line, purple cutting lines, the area here is 5%, which is 0.05. The area there is also 5%, which is 0.05. Okay? Yeah. So now basically we're measuring how far this x bar, the cutting line, the red one, to the middle mu, the blue one. So if the red one is go beyond the purple line, that's dangerous. Okay? So level of significance is the standard. They give you 5%, then you know where are the cutting lines here in the picture. And then you look at the x bar, you measure the x bar. Every day you get a different x bar. You get more tests, you get a different new average, new x bar, right? Yeah. So maybe 7 days is here and then 10 days here. They're both okay. X bar is still inside the purple line, between the standard, not too far away from mu. But if one day, maybe after 15 days or 30 days, x bar is higher than, is far further than, go beyond the purple line, that means dangerous. Okay, something wrong with Mercedes, you have to go to the hospital to make another test. Okay, you need something happened. Okay, something happened. Okay, so that's the meaning of alpha. Okay, yeah. Alpha is the fixed percentage given in the beginning. It's not moving. Mu is in the middle, not moving. But every time when you calculate, x bar is a new cutting line. So if x bar and mu are close enough between these two purple lines, that's okay. Keep mu if x bar is outside the purple line. That means the p-value is here, smaller than the given alpha, right? This yellow part is smaller, or this blue part is smaller than, we have a cutting line here, small blue area smaller than the level of significance, level alpha, then mu should be changed. Okay, so the problem is here. We keep this mu or change this mu. Okay, yeah. So that is the question in chapter 12. I know this is hard, this is long, so that's why I make this video. Okay, this video. So let me show you my 5 steps, explain the whole step, all the steps for this question, and then we will practice more in the class. Okay, in the class. Okay, so these are the 5 steps for the hypothesis test. Okay, so first you should know there are 5 given numbers. And then our goal is we set up x bar and then change x bar to normal distribution, standard normal distribution z. Okay, z. So we have a cutting line for x bar. Now we have a cutting line for z. So now what's p-value? P-value is the smaller area. Okay, smaller area. So this is the picture. We need the yellow area because this is mu, this is x bar, then that's the p-value. Right? So this is the case. X bar is smaller than mu, then that's the p-value. Okay, that's the p-value. So p-value is the smaller area. Okay, yeah. So for the question in lecture 10, they will give you the inequality. You need the blue area or you need the yellow area. For this chapter 12, you need to decide. Okay, which side is smaller, and then that's your p-value. Okay, that's your p-value. And then eventually you have to compare your p-value to the given number alpha, a small percent. Okay, if p-value is bigger, so this means keep mu. If p-value is smaller, that means x bar is too far away from mu, something wrong with the mu. Then you have to change mu. Okay, change mu. Okay, so that's the idea of these 5 steps. Okay.